Hi everyone, today I will introduce the latest light sheet microscope P. Capturing dynamic process in live samples is a hard task in biological images. Fluorescence would have a harmful effect on the samples. Light sheet microscopy allows for the rapid catching of the high-resolution fluorescent images with a minimal harmful effect. However, the light sheet is limited by the diffraction limits of the light and struggles to the image samples, which is smaller. Into 2014, the latest light sheet microscope is capable of the imaging biological systems in spanning four orders of magnitude in space and time. The technique has a much thinner light sheet. Smaller samples can be imaged at high resolutions. Latest light sheet is a combination of the techniques, includes SIM and bezel beams. Bezel beams has a high intensity spot surrounded by a lower intensity area, resulting a much larger depth of the focus while still retaining the high resolution. The lattice modified the beam with the SLM allows a lattice ultra thin beams and changing the waveform and introducing the structured pattern. The resulting of the light patterns is filtered and use a distractive interference to reduce the intensity of the outer circles of the bezel light sheet, resulting in a patterned light sheet that is a non-diffractive. The ultra-thin light sheet is transmitted through live biological samples, so it is usually for the cells. It features less photo damages and extremely fast capture rates and a super resolution level of the details. Briefly, the outline of the LC, which is selected by the AOTF and sent to the BS to create the lattice pattern. The BS is consisted of the SLM and AM. And the SLM is created square lattice profile and conjugated with a sample object plane. AM is required to clean the SLM diffraction pattern. SU is composed of two mirrors to use the to the dither to the pattern along the x-axis to the translated along the z-axis. The lattice light sheet is focused on EO, uh, base fluorescence is collected by with DO imaged onto the CMOS camera. Images showed the images showed the improvement of the lattice light sheet compared to a scanning bezel beam with a great resolution due to a thinner light sheet. In the dither mode, we could construct a low background lattice and nearly all the excitation is within the narrow depth of the focus of the high numerical aperture detection objective. This for the high resolution, high contrast 2D images at up to 100 frames per second for thousands of times point. The advantages, the image speed is up to the 300 frames per second in 2D and 5 Hz in 3D. The spiral resolution with a reduced phototoxicity. Higher axial resolution is about 0.5 micrometer, and the lateral resolution is diffraction limited by 205 nanometer. Dynamic image of the small live samples is about 1 cubic millimeter. Limitation, its performance degrades increasing with the depth because of the sample-induced aberration. And the pinhole crosstalk can lead the artifacts and poor SNR in thick fluorescent specimen because of the out of focus excitation. One of the application is a non-effective 3D image of the dynamics. The second one is the image cell-cell and cell matrix interactions. The third one is the image of the subcellular physiology of the developed embryos. Thank you for listening.